The final three mechanical locks that I'm going to discuss are the dimple lock, the Bell or Dudley lock, and the wafer lock. So starting off with the dimple lock, so you can see on the blade of the key you got a little black dot right there. That actually represents a depression in the key. The edge of the key is not beveled as before because it's not going to be having to interact with any pins as you insert the key within the lock. The lock itself is very similar to that of the pin tumbler lock. You got your housing, your cylinder or plug, your bottom pin, your top pin, and your spring. This time, however, the key is inserted on its side. And then basically, when the key is fully inserted, the bottom pin falls within the depression of the key, the shear line is met, and then you can turn the key to activate the mechanism. The next lock that I'm going to discuss is either called the Bell or Dudley lock. In this case, we're going to just put this right here because that represents an additional hole drilled from the bottom through the housing, through the cylinder. So you have a hole drilled through the housing, the cylinder from the top, and directly 180 degrees opposite of it coming up from the bottom. For this lock, you can see that the key has actually like a railroad track or a roller coaster track within the side of the key blade. So this is decoded by this mechanism right here. So you can see it's got a little peg, and that peg actually rides the track within the key. So you have the peg, you have the mechanism right here. When you insert the key, the peg falls within the track and rides the track up and down as you are inserting the key. Once the key is fully inserted, the shear line is met both at the top and the bottom between the housing and the cylinder, and then you can just turn the key and activate the mechanism. The final lock that I'm going to discuss is that of the wafer lock. So the wafer lock has a key very similar to that of the pin tumbler lock, but this time you have a wafer. So the wafer has a hole in it which matches the depth of the key, and it's got a little lip off to the side, and that lip actually goes with the spring. So this wafer can either be arranged so that the spring either pushes the wafer down or pushes it up. In this instance, you take the key, you put it inside the lock, and it goes right within the hole inside the wafer. And again, this will ride the key. When it goes down into the depression, the shear line is met again between the cylinder and the housing, both at the top and at the bottom, and then you can just merely turn the key and activate the mechanism. In order to prevent pick locking the lock, the manufacturers have set forth techniques to prevent easily picking the lock. So some of the techniques are, this is called a spool, where it has the top pin, actually has a ledge, both at the top and the bottom. At the bottom here, this is called a mushroom bottom pin. Alright, if you look over to the side, here is a multi-ridged top pin and a multi-ridged bottom pin. These are set and forth so that basically as you're trying to turn the cylinder is going to meet flush with the side of the pin, but then if you have it partially turned, that this top pin can no longer go inserted up into the housing because it's going to be stopped by this little ledge on the bottom pin. Also, when you have the cylinder slightly turned, that could actually cause the top pins to wedge in, and it'll tilt it off at an angle, making your lock-picking techniques very much more difficult. Also, they can use multiple pins. So basically they can either put biting cuts both at the top and the bottom to make your lock-picking technique much more difficult, or they can actually put them both on the sides as well. So you can actually have a four-sided key with biting cuts on all four sides. So that way you would have to pick all four of them pretty much at the same time in order to rotate that cylinder and unlock the lock. So there's also, of course, you can try drilling. Again, if you try to drill right through, make a new shear line between the cylinder and the housing, we have this technique, which is Era's drill resistance pin. So basically they have two ball bearings right here between the housing and the cylinder, and a rod pressing down from the top. So if you try to drill right and create a new shear line, you're going to meet these two hardened steel balls, which is going to cause your drill bit to come offline and prevent drilling that lock. Other techniques that they can use is hardened steel for the top and the bottom pins. So it's going to become much more difficult for you to drill through a hardened steel pin, either top or bottom, than if it was made out of softer steel. So these are some of the drill resistance techniques and anti-lock picking techniques that you may encounter, and they make your life really much more difficult. So if you are having a severe problem trying to actually pick a lock, you might actually be encountering some or perhaps all of these anti-lock devices.